To continue on the question of how we know the Earth is warming, we're joined on Skype by Spruce Schernemann, who's going to tell us about his work in Antarctica and how ice gives us information about climate change. Spruce, tell us about your work with ice cores.
Hi, well, yes, I'm a graduate student at the University of Washington in the Earth and Space Sciences Department, and I worked as a science technician and an ice core handler with research scientists on the West Antarctic Ice Sheet Divide Ice Core project. And I'm studying water isotopes in the ice cores, which tell paleoclimate scientists how temperatures have changed in the past. Paleoclimate refers to the study of past climate, and in addition, I compare the ancient changes with the greenhouse gases, like carbon dioxide and methane, to understand how the planet transitioned from the last glacial period to the present day. In Antarctica, when the snow falls, the ratio of heavy to light water isotopes is set by the temperature during precipitation. Isotopes are very small variations in the chemical composition of an element, but they can be measured. In the case of water, we measure the isotopes of oxygen, O16 and O18. We can then infer what the past temperatures have been over thousands of years. As the snow compacts to ice, it also traps pockets of atmospheric air. And we can measure these air bubbles preserved in the ice, which contain samples of the ancient atmosphere, including carbon dioxide and methane. Using the trapped air, we have been able to extend the record of carbon dioxide back to 800,000 years ago. The ice shows that the current rise in carbon dioxide actually began about 200 years ago during the start of the Industrial Revolution, when we began burning coal instead of wood. As the planet warms from the additional greenhouse gases we are emitting, we are seeing increased temperatures recorded by the isotopes, which also match the current instrumental temperatures. Together with the water isotopes, we see that the Earth has gone through long-term cycles in temperature and CO2 between colder glacial periods and warmer interglacial periods. The temperature changes are closely followed by changes in CO2, which further amplify the temperature changes, creating a positive feedback cycle.
How did the present changes compare to previous changes in the Earth's history?
Well, in the case of the last deglaciation, which is the melting of the ice sheets, it took roughly 10,000 years for the planet to warm, as the Earth's orbit provided small increases of incoming radiation from the sun. As the oceans warmed and the carbon cycle became more active, more carbon dioxide was released into the air, increasing the greenhouse effect, increasing temperatures, and so forth, until reaching this current stable interglacial period. In less than 100 years, we have added an equal amount of carbon dioxide from carbon locked in the Earth's crust than had been released from the land and oceans over the entire 10,000 years of the deglaciation. In addition, during the last 10,000 years, the Earth's orbit has caused us to slowly receive less incoming radiation. So we should have been headed toward another cold period, but instead the Earth has been warming.
Thank you, Spruce. Ice cores have been a key to understanding what's been happening with the climate over time. Ice core research is one way we know that the burning of fossil fuels has increased carbon dioxide into the atmosphere, and the rise in Earth's temperatures corresponds to the additional greenhouse gases. Thanks for telling us about the work you do.